Welcome to Day 12 of Wisdom Academy AI, my incredible wizards. I'm Anastasia, your super thrilled AI guide, and I'm absolutely buzzing with excitement today. Have you ever wondered how AI can predict numbers, like house prices or student grades, with magical precision? We're about to master the basics of linear regression, a foundational ML technique, and it's going to be an unforgettable journey. You won't want to miss a second of this, so let's get started. I've brought my best friend to say hello.
Hi, I'm Sophia, and I'm so excited to be here with you. Linear regression is the perfect way to start predicting with AI, and I've got a magical demo coming up to show you how it works. Let's dive into this adventure together.
Let's take a quick trip back to day 11, where we had a blast exploring ML algorithms. We learned that ML algorithms are the brains of AI magic, powering predictions and pattern discovery with their brilliance. We explored their types, supervised, unsupervised, and reinforcement, and learned how to choose and evaluate them, overcoming challenges along the way. We covered popular ones like linear regression, k-means, and Q-learning, each with its own magic. Today, we'll zoom into linear regression to see its power up close. I'm so excited to build on that foundation. Today, we're diving into the enchanting world of linear regression, and I can't wait to explore this with you. We'll uncover what linear regression is, the prediction magic that lets AI forecast numbers like a pro. We'll learn how it works by fitting a line to data, understand its key assumptions, and explore how to evaluate its performance. Plus, we'll build a model with a magical demo that brings it all to life. Let's predict numbers with AI wizardry. I'm so thrilled for what's ahead. Linear regression is our star today, and I'm so excited to share its magic. It's a supervised machine learning algorithm used to predict numerical values, like continuous outputs, in a simple yet powerful way. For example, it can predict house prices based on their size, helping us estimate costs accurately. It works by fitting a straight line to the data points, finding the best relationship between variables. This makes it the simplest way to predict with AI. I love how elegant it is. Why use linear regression? Let's find out. I'm so thrilled to share its benefits. It's simple and interpretable, making it perfect for beginners who are just starting their AI journey. It works best for linear relationships, where data follows a straight line pattern, like a clear trend. It's also fast to train and easy to implement, saving time and effort for quick results. For example, it can predict sales based on advertising spend, helping businesses plan better. Linear regression is a foundational tool for AI wizards. I'm so excited to see its power. Let's uncover how linear regression works, and I'm so excited to break it down. It finds the best fit line for your data points, creating a straight path that captures the trend. The equation is y chaten mx plus b, where m is the slope and b is the intercept, defining the line's position. It minimizes the error between predicted values and actual data points, ensuring the best fit possible. This is done using a method called least squares, which optimizes the line perfectly. It's like drawing a line through magic. I'm so thrilled to see it in action. The math behind linear regression is fascinating, and I'm so eager to share it. The slope, m, shows how much y changes for each unit of x, defining the line's steepness. The intercept, b, is where the line crosses the y-axis, setting its starting point. The error is the difference between predicted and actual values, which we want to keep as small as possible. Our goal is to minimize the sum of squared errors, ensuring the line fits the data best. It's simple math that leads to magical predictions. I love how it all comes together. Let's look at a magical example, predicting house prices with linear regression. We use data where house size, x, predicts the price, y, showing a clear relationship between the two. Linear regression fits a line through this data, allowing us to make accurate predictions based on the trend. For example, a 1,500 square foot house might be predicted to cost $300,000 based on the fitted line. This helps buyers and sellers make informed decisions about pricing and budgeting. It's a real-world spell for price prediction. I'm so excited to see its impact. Linear regression has key assumptions we need to understand, and I'm so thrilled to share them. First, there must be a linear relationship between x and y, meaning the data follows a straight line trend. The data points should be independent, so one point doesn't affect another, ensuring unbiased results. Errors should be normally distributed with constant variance, meaning they're consistent across predictions. In multiple regression, we avoid multicollinearity, where predictors aren't too correlated. These assumptions ensure our magic works perfectly. I love how they guide us. Checking the linear relationship is so important, and I'm so excited to show you how. We plot the data in a scatter plot with x versus y to see the pattern of the points. We're looking for a straight line trend, indicating a linear relationship between the variables. For example, house size versus price often shows a linear trend, making it perfect for linear regression. If the trend isn't linear, we might need to try other models, like polynomial regression instead. This is a crucial step for accurate predictions. I'm so glad we're covering it. Let's compare simple and multiple linear regression, and I'm so thrilled to explain the difference. Simple linear regression uses one predictor, x, to predict y, like using house size to predict price. Multiple linear regression uses many predictors, like x1, x2, and more, to predict y, such as size and location together. For example, predicting house price with just size is simple, but adding location makes it multiple, capturing more factors. Multiple regression adds complexity, but often improves accuracy for better predictions. Both are powerful tools for AI magic. I love their versatility. Here's a magical example of multiple linear regression that I'm so excited to share. We use data like house size, location, and number of bedrooms to predict the price, considering multiple factors at once. The equation becomes y sart b0 plus bxx1 plus b2x2 plus b3x3, where each x represents a predictor and b is its coefficient. This allows us to predict the price by combining all these factors into one model, giving a fuller picture. It's often more accurate than simple regression, as it captures more influences on the outcome. This is a magical way to handle complex data. I'm so thrilled by its power. Evaluating linear regression models is so important, and I'm so eager to share how we do it. We use metrics like mean squared error, or MSE, to measure the average squared difference between predictions and actual values. R-squared tells us how well the line fits the data, with values closer to 1 meaning a better fit. For multiple regression, we use adjusted R-squared to account for extra predictors, ensuring fairness. A lower MSE and higher R-squared indicate a better model, showing our predictions are on track. These metrics help us perfect our magic spell. I love seeing the results. Let's dive into mean squared error, or MSE, and I'm so excited to explain it. MSE is the average of squared errors, where the error is the difference between the predicted value and the actual value. We square the errors to penalize larger mistakes more heavily, ensuring the model focuses on reducing big errors. A lower MSE means better prediction accuracy, as the model's predictions are closer to the actual data points. This makes MSE a key metric for evaluating our magical model. I'm so thrilled to use it. R-squared is a magical metric, and I'm so thrilled to share how it works. It measures how well the regression line fits the data, showing the proportion of variance explained by the model. R-squared ranges from 0 to 1, where 1 means a perfect fit and 0 means no fit at all. For example, an R-squared of 0.85 indicates a good fit, meaning 85% of the data's variance is explained. We also use adjusted R-squared for multiple predictors to avoid overestimating the fit. This is a magical way to measure our model's performance. I love its clarity. Linear regression has challenges, but I'm so determined to tackle them. It assumes a linear relationship, so it may fail if the data is nonlinear, requiring a different model. It's sensitive to outliers, which can skew the line and lead to poor predictions if not addressed. In multiple regression, multicollinearity, where predictors are too correlated, can cause issues with interpretation. There's also a risk of overfitting if we use too many predictors, making the model too complex. We'll overcome these with magical solutions. I'm so excited to solve these puzzles. Let's overcome linear regression challenges, and I'm so thrilled to share these fixes. First, check for linearity using scatter plots to ensure the data fits a straight line before proceeding. Remove outliers or transform the data, like using logarithms, to reduce their impact on the model. Address multicollinearity by using feature selection to pick only the most relevant predictors, avoiding overlap. Use regularization techniques, like ridge regression, to prevent overfitting by keeping the model simpler. These are magical fixes for a better model. I'm so excited to apply them. Linear regression has amazing real-world applications, and I'm so inspired to share them. In business, it can predict sales based on marketing spend, helping companies optimize their budgets. In healthcare, it predicts patient recovery time, aiding doctors in planning treatments effectively. In finance, it's used to predict stock prices or assess risk, guiding investment decisions. In science, it analyzes experimental data trends, revealing insights from research. Linear regression is a versatile spell for many fields. I'm so thrilled by its impact. Before we dive into our magical linear regression demo, let's get ready like true wizards. Ensure Python and Scikit-learn are installed. Run pip install Scikit-learn if you haven't yet, to have your tools ready for action. Use the houseprices.csv dataset with size and price, or create it now with a script I'll share in the description. Launch Jupyter Notebook by typing Jupyter Notebook in your terminal, opening your coding spellbook for the demo. Get ready to predict house prices like a wizard. I'm so excited for this magic. Now, wizards, it's time for a magical demo that'll leave you spellbound: linear regression in action. Sophia will use Python and the Scikit-learn library to predict house prices based on their size, showing us the power of numerical prediction. This demo will take our dataset and build a model to forecast prices, bringing the theory to life before our eyes. It's pure magic, and I can't wait to see it unfold. Over to you, Sophia, to cast this spell.
Hi, I'm Sophia, your demo wizard for Wisdom Academy AI, and I'm so excited to cast this spell. I'm using Python and Scikit-learn to apply linear regression on a house prices dataset with size versus price, predicting costs with AI magic. I split the data, train the model, and predict prices. Look, an R-squared of 0.82, a great fit. The magic of AI prediction power is alive. Back to you, Anastasia, with a big smile.
Wow, Sophia, that demo was pure magic. I'm so impressed by your skills. Let's break down how it worked for our wizards to understand the process. Sophia used Python and Scikit-learn to build a linear regression model on a house prices dataset, predicting costs with precision. She loaded and split the dataset into training and testing sets, trained the model on the training data, then predicted prices and evaluated the fit with R-squared 0.82. This process brings linear regression magic to life, showing its predictive power. I love how this makes AI so tangible and exciting. Here are some tips for using linear regression, and I'm so thrilled to share my wizard wisdom. Start with simple regression if you're a beginner, as it's easier to understand and apply right away. Always check the assumptions, like linearity, before building your model to ensure it works correctly. Use visualizations, like scatter plots, to understand data trends and confirm the relationship is linear. Experiment with multiple predictors if your data needs it, adding more factors for better predictions. Keep practicing to perfect your magic. I know you'll become a linear regression wizard. Let's recap day 12, which has been a magical journey from start to finish. Linear regression is a powerful tool that predicts numbers with magic, helping us forecast values like house prices. It fits a line to the data using the equation y 1cs mx plus b, finding the best relationship between variables. We learned its key assumptions, like linearity, and how to evaluate it with metrics like MSE and R-squared, ensuring accuracy. We also tackled challenges, like outliers, with smart solutions to keep our model strong. Your task: build a linear regression model using Python and share your R-squared in the comments. I can't wait to see your magic. Visit wisdomacademy.ai for more resources to continue the journey. That's a wrap for Day 12, my amazing wizards. I'm Anastasia, and I'm so grateful for your magical presence on this journey. I hope you loved learning about linear regression as much as I did. You're truly a wizard for making it this far, and I'm so proud of your progress. If this lesson sparked joy, please give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow, we'll dive into logistic regression basics. I can't wait to see you there for more magic. Sophia, any final words?
Hi, I'm Sophia, and I had a blast showing you linear regression. Day 13 will be even more magical with logistic regression, so don't miss it, wizards. See you soon.